This is a demonstration of how you might go about analysing a braking test profile. So the first thing we would need to do is load a profile, and we'll pick braking 30. We accept that. We zoom into the area of interest and we can see the trajectory overlaid on the test track aerial photo. First thing we might do is check the velocity chart. So this tells us velocity versus time. Our initial concern is that the braking tests were done at various velocities. So what was the velocity for this test? And by identifying a position on the chart, we can find that the peak velocity was 80 kilometers an hour. So we know what the test speed was. We now have some other analysis functions. So we can hit the averages button and calculate, and that gives us the average velocity over the test, 46.6 kilometers an hour, the duration of the test, which was 13.4 seconds, and the maximum and minimum velocities reached, which is 0 and 80, which is what we expect. We can then close that. We can do an estimate of distance travelled. So over that period, we hit calculate. We travelled about 174 metres. This is calculated from integrating the velocity to get distance. So we have a distance value, we close that. We can then close that chart, and we're now interested in the pitch roll. And what they tell us is that there was probably an offset active, the box wasn't level in the horizontal plane, and so we would need to apply some sort of calibration factor in the file's calibration menu option to bring them down to around the 0 angle mark. They'll vary a bit, but they're clearly at about 7 degrees. And they need to be corrected. Finally, the chart of most interest is the acceleration chart. And so again, we can tell from the, if we turn off the GX, which is the braking, the longitudinal acceleration, the magenta is the lateral and the blue is the vertical, and we can see the blue is fairly central, but the lateral acceleration seems to also have a small offset, so that would need to be addressed and corrected as well. We can close, we need to get GX now. So if we turn the other profiles off, this is a filtered display. It starts at about minus 0.2 G, so again we need to apply an offset. It would be expected that this would start about 0, because the first peak is the acceleration from rest, and then the acceleration decreases as the vehicle reaches a constant velocity, and then the braking maneuver is indicated by the substantial spike. We can use the ability to display individual points on the chart to work out that there might have been a minus 1.3 G braking operation. And then we find the braking level decreases and there are some oscillations, and then the final drop back to 0 represents the vehicle coming to a halt. We're also able to work out averages, so if we pick the average button and we hit calculate, we get the minimum, average and maximum G values for lateral, longitudinal and normal G, and that gives you a range you can check between this run and other runs. And that's a rough idea of how the braking analysis would be done.